Hello everyone, welcome back. This is Mr. Osem Wasapi, and in today's video we'll be looking at stress and strain under the deformation of solids. Alright, so before we begin, don't forget to like and subscribe to the channel. Alright, let's get to it. So let's understand what stress and strain is. Now, one thing you need to understand is this: that all solids are able to stretch to an extent or an amount to which they are stretched, but this is entirely dependent on the force applied. Now, with this in mind, you need to understand the terminologies attached to this topic. So let's try and define these two words. Let's start with stress. Now, stress is mostly symbolized with sigma. So this symbol is called sigma. But stress is defined to be the force applied per unit area. So the force applied per unit area. Let's not forget this. Now, we also need to be mindful of this. Stress is measured in the units called pascals. So we just say PA. Now, 1 Pascal is equivalent to 1 Newton per watt meter squared. So basically, one would put the units as Pascals, and another would just put Newtons per meter watt squared. Everybody's correct in this statement. Alright, let's shed more light. So, stress is the force per unit area. Units pascals. So in our formula, we know that F is force and A is area. Now, one thing you need to know about this area is that it entirely depends with what you're being asked to find. If the area being considered, or the material to be precise being in consideration, is cylindrical, or say you are considering the area of a circle, then you take the area to be equal to pi d squared over 4. So this is the area of a circle. That is if they say that the material is cylindrical, because if you apply a force on the surface area of a cylindrical material, then the area will be equivalent to pi d squared over 4. But if you're taking in consideration of a rectangle or square, if the material at hand is a rectangular material or square material, then the area will be equivalent to L times B, which will just be LB. Don't forget this. Very important. Now, let's move on to what we call strain. What is strain? So now, strain is simply just a ratio of the change in length to the original length. It shows you how much the material had changed as a result of stress. So it's defined to be the change in length, so the ratio of change in length to the original length. Let's be mindful of this. Now, stress is symbolized with an epsilon. So this symbol is what we call epsilon. Like that. Alright, so with this in mind, we need to bear that the formula for strain will be given as epsilon is equal to the change in length over initial length. Now, the change in length, remember, is extension, and the initial length is just the length. So let's not forget that. Now, one thing you should know is this: that strain has no units, because you are dividing meters by meters. It's length over length, so the units will cancel out, so it's dimensionless, so it has no units. Let's not forget that it has not units. So stress and strain are defined in these ways that we have actually considered. Now I want us to discuss the types of stress that we have. Okay, not really discussing them, let's just talk about them in basic. So what are these types of stresses that we might come across? So the first type of stress that we have is called the compression stress. The compression stress, I could just say the compressive stress. Now the compressive stress is a stress that the material experiences when you have this kind of action. For instance, you're trying to squeeze something inwardly. Yeah, that is compression. So the stress created by that is simply called what? The compression stress. Then we have what we call the tensile strength. Now this tensile strength is the strength that the material will experience when it's being pulled apart. Say you were trying to pull a material apart, the material will experience what we call a tensile strength. Then the last type that we can consider is what we call a shear stress. Now a shear stress is a stress that you maybe use simple examples. Say you are trying to dry your clothes after washing. Now when you twist your clothes, you are applying what we call a shear stress. So a shear stress is a stress created out of twisting a material. Alright, now let's go back to Hooke's law. Remember, Hooke's law states that provided that the proportionality limit is not exceeded, the force is in direct proportion with our extension. Now in this way we can say stress is directly what? Proportional to what? Strain. To what? Strain. That's what the Hooke's law states. So now stress is in direct proportion with what? Strain. Simple as that. Now what happens if you relate stress and strain? Now the relationship between stress and strain is called the modulus of what? Elasticity. Modulus of elasticity. Now the modulus of elasticity is sometimes called Young's modulus, also called Young's modulus. So now this modulus of elasticity or Young's modulus just shows the relationship of stress and what? Strain. The symbol for Young's modulus is a capital what? E. So Young's modulus is equal to what? Stress over what? Strain. This is the Young's modulus. Now the units for Young's modulus are simply just gigawatt pascals because the size is quite big. Alright, so now we know that if E, which is Young's modulus, is equal to stress over what? Strain, units pascals, we can find means of manipulating this formula. In a way, say we have been asked to find a different quantity other than the Young's modulus. Because be mindful, E is equal to the stress over strain. Now stress is force per what? Unit area divided by strain, which is extension over initial length. So Young's modulus is equal to F over A times what? L over what? X. So Young's modulus is simply just FL over what? AX. So this is also one of the equations for what? Young's modulus. Now the modulus of elasticity is not the only modulus that we have. It's just that this explanation is focusing more on deformation of solids at an A level, not at an A level to say. So just a quick thought, if you were asked, say, to find the extension of a material, you can relate such by using the Young's what? Modulus. You can say, since you know that E is now equal to, remember we said E is equal to FL over what? X. E is equal to FL over what? X. You can just make X of the formula. So it's going to be E X being equal to what? FL divided by EA divided by what? EA. And the extension is the applied force, which is a load, the force attached For instance, if you consider something like spring to be the force attached to the spring, which will be the force in consideration, over the length, which will be the initial length, over the Young's modulus, that is if given, and the area of that particular item, material. Okay? Yes. Be mindful of that. If it's a wire, we'll consider the area of a cylinder, because wire is, if you can visualize it, there's a circle, so be mindful of that. So now, this is what you have to know, the basic scale of stress and what? Strain. In future, we'll look at what we call the stress strain curve, which talks a lot about the tensile testing of a material. So we'll see how best we can get to that point, but I hope you understand on the basics of stress and strain. My name is Mr. Hussein Mwasapi. Don't forget to like and subscribe to my channel. If you have questions, you can contact me on WhatsApp on that number, or the number in my description. Remember, subscribe. Alright. Strategize before you become a statistic. Let's try and push for that A+.